Hello and good morning, everyone. This is Jonathan Nicholson with ISP Supplies, and today we are presenting to you a product that we feel has a great application in our WISP market. A connectorized 24 gigahertz solution available in dish sizes from 1 foot all the way up to 4 feet. The manufacturer is Racom, based in the Czech Republic. Their solution is brought to us today by their U.S. representation, Cable AML. On the line with us today, we have Philip Rushton. He is business development for Cable AML. He has prepared some slides to go over with us today. Please submit all of your questions, and we will go over them after the slide presentation. We'll also be recording today's webinar and posting it on YouTube and social media. So please welcome Philip Rushton from Cable AML. Philip, the floor is all yours.
Thank you very much, Jonathan. Good morning, everybody. Okay, let's get this on the road. Decided to title this presentation as Extending 24 Gigs because we think we can offer a little bit more. So this is the list of contents that I will be walking through today. As Jonathan said, we can pick up some questions at the end of this. It's very much what we put out on the notification of this event. There haven't been any changes to that. A very good place to start with any discussion on this is back to the regulations. There's a lot of requirements around microwave radios, but really the one that everyone really focuses on is actually what we can transmit and what we can do with it. So as I have had a number of questions on all of this, I've actually listed out here on this slide a link and then also the relevant paragraphs. So you can actually go to the regulations. Whilst it takes a while to actually get to the final paragraph, when you get there, it's actually not that long, which is quite nice. So what I'm showing here is a little summary of it. Key points here is we've got 200 megahertz in the US. The actual, in terms of power level, it is only specified as an electric field strength measured at 3 meters. It's 2.5 volts per meter. And then with that, you've got to couple that obviously with an antenna, and the gain must be at least 33 dBi or have a maximum beam width of 3.5 degrees. Now, the thing to note about the requirements here is that there is no EIRP limit specified. In talking with a number of customers, I have had this raised quite a few times that people think there's a limit in the 30-odd dBm range. There isn't. The limit is an electric field strength measurement, and that's actually quite important. There are some formulae that you'll see out there where you can work between electric field strength and EIRP. But the point to note with all of that is that the derivation of those formulas does tend to assume that you're operating in the far field from the antenna. And with 24 gigs, with the kind of antenna sizes that we use, we're very much in the near field at the 3 meter measurement. So the thing to focus on is electric field strength. I've made a note at the bottom here of the approval of the Racom Ray3 product. There's the FCC ID there and the approval date. So it's approved in the US middle of last year, so it's still relatively new in the market. The test conditions are important here. The product actually transmits with a power of up to 10 dBm, and all the testing was done with a 4-foot antenna, which actually had a gain of 46 dBi. So in terms of deployments, it is perfectly legal to use any deployment which is less than those numbers, less than up to 10 dBm or less, and then also an antenna gain of anything between 33 and 46 dBi. The testing itself, just for completeness here, was done professional testing in Texas. That's where the approval lab was done. If anyone's interested, I can send you the link on the FCC website where you can actually download the test reports and all of the other stuff that was submitted. But it was a very good and thorough job that was done there.
And we can post that link with the recording of the webinar as well. We can make sure we put the link in there in the description.
Yes, that would be very helpful at the bottom. Yeah, I'll send that over to you, John, a little bit later. Now, as all of you know, because you're the guys that deploy this sort of band, there are some distinct challenges at 24 gigs. I just want to talk around some of these. First one is the obvious one, and that 24 gigs is obviously unlicensed. And then there's always a possibility here of interference from other people. But I think, my observation here is that really interference tends to be mutual. If someone's interfering with you, you're probably interfering with them. Therefore, there's a good case to try and come to some sort of agreement on how you work things. But one of the issues with all of that is that you need to be able to have a product that you can potentially make changes to, so you can work with other people. And I will be talking more about the way that the Racom product can work with the interference. Fade margin. This is probably the most important thing that I think is really a real challenge around 24 gigs. And just to be clear, fade margin is really the extra power that you've got within the system to take into account any interference or any kind of degradation that you have on the link. It's very important to make it in terms of reliability, and that's really what we're bothered about here, is that you have adequate fade margin. There's no point in putting a link up on a nice sunny day, having it working, and then when it all turns a bit cloudy and starts to rain, the link fades. That's not going to be a good design and not satisfactory to your customers. So fade margin is by far the most important. We will discuss some of that. So the main causes of fade margin, tends to be rain and also multipath, which we'll go through. So let's talk a little bit about the rain attenuation here. First of all, it obviously increases exponentially with the intensity of the rain, and it also increases significantly over the larger distances. One interesting point to note here is that with a horizontally polarized signal, you get greater rain attenuation than you will with a vertically polarized signal. The Racom Ray24 uses vertical and horizontal polarizations. One polarization in one direction and another polarization in the other direction, and you can select between the two. But in terms of doing a deployment, polarization on the direction where you want most capacity. And I can show you how that all happens as we go through the presentation. Now, rain attenuation is there's an ITU standard that defines a method for estimating attenuation. And as part of this, the standard actually takes the whole Earth, the whole globe, and divides it into little eighth of a degree grids. And then there's an average rainfall defined for each grid. And just to give that eighth of a degree into some sense, that's roughly about 7.5 miles square, something like that. So it's actually quite finely divided, which is quite good. This is taken from the standard, actually a slightly earlier standard version of the standard, but it does sort of show a little bit of what it is. And I reckon, looking at this and where ISP Supplies is based, I think something you sit around about the 50, 60, maybe a bit over 60 millimeters per hour for 0.01% of an average year, which is all a little bit difficult to follow, but 0.01% of an average year corresponds to roughly 2 hours in an average year, something like that. And under those circumstances, you're getting probably a bit over, under that time, you're getting maybe a bit over 2 inches of rain, something like that. This is a useful graph, and it just actually really shows this horizontal vertical polarization difference. This actually wasn't it from a later version of the standard? It's actually an earlier version of the standard where they used to have rain zones. They divided the Earth up into 15 rain zones. So this was back in the early 2000s. But what this graph does show very clearly is just the difference in attenuation for horizontal and vertical polarizations. So where ISP supplies is based is probably around about Ray zone M, something like that. So you've got a difference of maybe 2 dBs per kilometer, depending upon the different polarization that you pick. So this is a significant thing, but this is quite a nice graph, just showing the kind of the quantity, the attenuation that you could expect. All right, let's move on to the next one, which is multipath fading. And this is another very important thing that we've got to consider. At 24 gigs, the wavelength is only 12.5 millimeters, about half an inch. So if you've got a path difference from a direct signal to the reflected signal, it doesn't take too much to end up with some fading. And fading can either be flat, where you've got a fixed type of reflection, or it can be frequency selective, depending on what goes on. So it's an ITU standard that does define a probability for kind of working this outage out. And that's something that when we go through the simulation of the links, we can actually see that. An easy way to kind of get a good view of what the sort of effect of multipath is actually with the Fresnel zone. And the Fresnel zone, really all it is, it's shown there as a nice ellipse in the diagram. And the edge of the ellipse, if you kind of imagine a ray from one antenna going down and actually touching the edge of the ellipse and then reflecting off at that point back to the other antenna, the shape of that ellipse would mean that for the first Fresnel zone, the reflected signal has exactly half a wavelength more path length than the direct. So you would get, in that sense, complete cancellation. So that's really the definition of the first Fresnel zone. You then get second, third, and fourth, which are just multiples. Hopefully you can all see the little table that I've got there to the right-hand side. But that kind of gives you the radius of the Fresnel zone, depending upon what you're doing there. So for roughly something like about a 4-mile link, which is equivalent to basically about 6 kilometers here, you've got a radius of the Fresnel zone of about 4 meters, something like that. So we need to really make certain whenever a deployment is done that there is nothing, no obstructions at all within that Fresnel zone region, or else you are likely to get some kind of multipath fading, and that would not be good. Okay, let's just move forward, and I'll just talk a little bit now and introduce Racom as a company. Now, Racom is probably relatively new in the US market, but it's actually a very long-standing company. And it's formed in 1989 in the then Czechoslovakia, and it's a leading supplier of SCADA and telemetry data transfer systems into the sort of industrial wireless space. It is based in the Czech Republic. As Czechoslovakia split politically into the Czech Republic and the Slovak Republic, and I can't remember when, but it was probably about 1990, something like that. It's now in the Czech Republic. Key thing is that this company was founded, as I said, back in '89 by a few individuals, and they still own the company, and it operates with no debts. So it's a very well-established, trusted supplier, been around for years, and will no doubt be around for many years to come. So as Jonathan said, I work for Cable AML. Cable AML is really Racom's kind of sales and technical support partner in the US. They don't actually have an office themselves in the US, so that's very much what we do for them. And then helping with that, it's obviously ISP Supplies, which is really your go-to partner for buying the products from distribution. Racom do have three main product ranges. The one we're going to really talk about today is the microwave links. But you can see there on the slide here, they have their radio modems and also their cellular routers as well. Those are their other two main product ranges, mainly used, as I said, within the industrial market for controls. Let's talk about the Ray3 itself. The Ray3, as the name implies, is actually the third generation. There was a Ray 1 and a Ray 2, and now we've got the Ray 3. So the original Ray itself, the Ray 1, was actually launched in 2009, and then followed by the Ray 2 in 2014. And then the Ray 3, obviously, it was launched last year. So whilst the Ray 3 is a relatively new product, certainly into the US market, it is more of an evolution. So a lot of the real design and the technology is actually very well established and very mature technology. As they've gone through, they've obviously improved and enhanced the product, but it still keeps its same sort of reliability and focus on quality that the product has always had. So it is very much a mature, tried and tested technology. So some of the main features that we've got here, whenever the product has been designed, it really is designed to be robust and have really exceptional sensitivity. The little picture that's shown on the right-hand side here shows some of the deployments, and there's a good amount of ice and snow on these things. So they really are intended to give good performance under the most challenging conditions. The fact that they can have a range of antennas really allows this product to work over some extreme distances for 24 gigs. And that's really very important. The receivers also have a very high sensitivity. With the high transmit power plus 10 dBm, you can get really a good range out of this. Different antenna sizes are supported. 1, 2, 3, and 4 foot is the antenna sizes we go. 4 foot are really quite large, as you know. 1 foot makes a very neat, tidy installation. Now, there's some questions here about actual capacity. In any one single direction, the product has a maximum throughput of 1 gigabit per second, and it's very much advertised as a 1 gigabit per second radio. Some people do like to look at these things as the capacity as a sum in both directions. If you kind of do that on this product, you get about 1.6 gigabits per second, and I'll explain why you get that. But in essence, the capacity of the radio is a 1 gigabit per second radio, and that's the way to look at it really relatively in the marketplace. It's got quite a range of channel sizes, up to 112 megahertz, and also modulation up to 4096 QAM. It is a true FDD radio, which is an important feature, and it does have a very low latency associated with that as well. The original design of the product used 250 megahertz of spectrum, and that's really because that's the FC requirement. There, at the maximum, 112 megahertz in one direction on one polarization, and then 112 megahertz in the other direction on the other polarization. There you can get 2 times 2 gigabits per second, 1 gigabit per second through the product. Under the FCC regulations, where we only have 200 megahertz, there if you want a symmetric band system, a symmetrical throughput, you have to operate at slightly less channel bandwidth, about 80 megahertz in practice in each direction. So you are running 713 megabits per second in each direction. at 2048 QAM. You can go actually up to a little bit more if you like, and have an 80 meg channel in one direction and a 100 megahertz channel in the other direction. That you can do within the 200 megahertz, and that will give you a little bit more capacity, and that's how I came out with that figure of 1.6 on the previous slide. There are, as I said, a very wide range of different channel bandwidths and modulations that you can select. There's actually 12 channel bandwidths and 11 different modulations, all the way from 3.5 megahertz right up to 112 megahertz. And that's really makes this product really very, very useful, particularly dealing with interference and any issues like that, because you do have the ability with this product to select exactly where you want to transmit. So if you do have some interference, you could reduce your channel bandwidth a little bit and move it into a band where the system is able to perform. This is a little bit of what we're showing on this particular slide. It's a bit of a busy slide, but let me just try and walk you through it. The top picture is kind of the system with a conventional hardware duplexer. The Racom Ray3 does not use a hardware duplexer, but if you do use it, as you can kind of see here, if you've got a piece of spectrum and you've already got somebody else using that in a couple of 56 megahertz channels, and you want to try and make use of the spare spectrum that isn't being used, if you've got a hardware duplexer, you can only squeeze in between the a bit of occupied channel and a bit of noise. You can only squeeze in a 14 megahertz received signal, and then that correspondingly means you need to have a 14 megahertz transmit signal on the other side because of the hardware duplexer that you've got sitting in the middle. That's the problem with that. When the Ray3 was designed, they did away with a hardware duplexer, so you don't need any of that. So the key point here is that you can have asymmetric channels, and you can make use of spare spectrum, and that's really shown. If you go and look at the bottom left picture, you can see there that on the transmit, they're able to squeeze in 112 megahertz of spectrum in, say, a downstream direction, and then in an upstream direction, we can squeeze in this little 14 megahertz channel as the back channel. So there's that possibility. Or, as is shown in to deploy more than one system, if you like, quite easily. And you can select the little bits of spectrum that you actually want to use for transmits and receives, and you can move them around really wherever you like within the 200 megahertz. The only kind of restriction there is to all of that is that when you do that, there must always be at least 18 megahertz of spectrum between your transmit and your receive. But you can set those bits of spectrum up wherever you like across the 200 megahertz. So you can operate sympathetically with other equipment that you may be deploying, or indeed if you've got some interference and noise, you can easily work your way around that. So talking a bit more about the flexibility of the system. The little picture to the right there shows a whole load of Racom antennas all mounted really right next door to each other. That's perfectly possible with these deployments, all due to the flexibility of the system. The actual radio itself is very much all software defined. There's basically one piece of hardware which operates at both ends of the link. And everything can be configured on that and done so remotely. So it's in that sense very, very flexible. I've previously mentioned this 18 megahertz that you need between the transmit and receive channels. but that's not really too much of a restriction. So let's jump on to the next bit. So the system itself has three sort of the interface into the Ethernet interfaces to this. You've got a lot of flexibility with this. You can have copper interfaces, you can have fiber interfaces. There is also internally in the system, there is an Ethernet switch, which is really quite unique and very, very powerful. Bearing in mind you do have two Ethernet ports on the product, you can switch traffic between those ports and you can route traffic across the link from one port to the other port or however you want. There's a lot of flexibility in that. That's really a very powerful feature. From a management perspective, there's really everything you would expect. There's a web tool, which we will be going on to a little bit later in this presentation. There's a set of tools that you can have running on a mobile phone to help you with installation. And then there's also a CLI to that. The product also does support SNMP. So if you have chosen management tool, you can easily integrate the product into that and see happily what is going on. From an antenna perspective, as I mentioned before, there's three different sizes that we can work with. Currently, there are 3 vendors for antennas that are approved for use on the product: Leax, Gyrus, and also Andrews, or Comscope as they're called now. Let's just talk a little bit more about the Ethernet and how the system is powered. As I said, there are 2 Ethernet ports on the system. One of them is the port that is also used for powering, and that is a copper Ethernet port. And in fact, in most installations, most people just plug an Ethernet cable directly into that port. And on the little diagram here, you can see on the picture, it's actually the one to the left, and the diagram at the bottom, it's the one at the bottom of it. That's the port that you can just power through power over Ethernet and also get your Ethernet connection to that. What a lot of people do is that they do also use a fiber connection, and the other port on the system just takes an SFP that can be a copper SFP or a fiber SFP. You can put either, and that you can just plug in and connect that way as well. And each of those ports, as I said before, are the ports on the switch. Right from day one, this product has been designed to be as reliable as possible. It has very good surge immunity and obviously electrostatic discharge. These are 2 important things. An MTBF of greater than 85 years, which really makes it very robust. And as I said before at the beginning, this is an evolution of a product that's been around since 2009. So they have a lot of data to the real practical reliability of the product. So that's a good figure. Housing it, the product is aluminium, cast aluminium housing. So that's all very robust. It is compatible with a Ray3. There are actually some Ray3 deployments in the US. The Ray3 is actually FCC approved. So if anybody does have a Ray2, they can easily update to the Ray3 if that's what's required. Okay, what I want to talk about now is a little bit of some of the advantages of the Ray3, really over some of the other solutions that are out there. Now, this is always a very difficult topic to cover because in truth, we don't really know too much about what the other products are, and I'm not going to speak to them. There are a lot of very good and well-designed products out there at 24 gigs. But I think really as you look at purchasing decisions here, I think there's some things that are worth considering, and that's really what I want to focus on. So the first thing that always bubbles up straight out of the blocks is always price. Everybody wants to buy the cheapest possible product. But I think what everyone's got to what's got to be considered really on price is to really look at the whole life cost of the product, really in relation to the value of the traffic that's running across the link. So these backhaul links, and a lot of you guys that deploy these things, you've got a lot of customers hanging on the back of this. You need to have something which is really solid and reliable. So the thing is, in my mind, price is important, but there's a number of other things that we really are worth focusing on. A lot of people will talk about the throughput, and that's another kind of top line number that is discussed. Very much within the microwave business, point-to-point microwave business, the convention is that the throughput is specified in one direction, and that's a product as advertised. However, I do see that some vendors do it as a sum. I just mentioned that really, just to sort of be aware of that. The Racom Ray3 is a 1 gigabit per second product. So that's just worth bearing in mind. The other thing that's important here is that in terms of the advertised throughput, it is always specified as a line rate for the RF modem. And whilst this is all nice and clean and clear, from a deployment perspective, it's not really that relevant. What you're bothered about is what actually is the real Ethernet throughput that you will see. And that is always going to be slightly less depending upon the efficiency of the MAC layer that has been implemented in the radio. Racom do publish the actual Ethernet throughput depending upon the traffic type and Ethernet packet size. It's actually in the manual. I can show you that later on if someone would like to see that. So that data is all published, and in terms of how you're going to deploy it, that's something that's very important to look at. Other things I think that are really important, and that is flexibility. As I always think, every deployment that is done is unique. They're never the same. Every physical deployment has its own challenges. And one thing that's really, really important is that you've got a solution where you've got flexibility on it. So the Racom product, you can change antenna types, 4 different antenna types. You've got the flexibility of being able to use what bits of spectrum you like across the 200 megahertz. That's really very powerful. So having that flexibility of different antenna types, I think it means that you can really tailor the deployment to exactly what's required, and also the fact that you're not going to be using more power than you really need, because that just ultimately gives more problems potentially further down the line. Latency is something that is a really important feature for backhaul product. The Racom product is a full FDD technology. We do have extremely low latency of a couple of hundred microseconds, or sub 200 microseconds to be precise. That is really, really important. Things do tend to add up. But I always think the most important feature is link budget. And that's not something that's ever really published. People quite often publish the throughput of their product, and that's all the good things about the product. But actually, the link budget is actually probably the most important feature, because it tells you how reliable the product is really going to be for any given deployment. You don't want to overpay as well. You don't want to have more link budget than you need, because you then end up with an expensive solution. But if you have less link budget than you actually need for a deployment, the system will be unreliable, and that's no good for your customers. So link budget is probably, if I have to pick on all of these various features here, I would say that is the most important thing that people need to focus on. Right. So what I thought we'd like to do is actually show you all an actual simulation. Now, you probably can't see that clearly on this slide because I'd imagine all these numbers are a little bit short, a little bit small. But what I'm going to do is go onto the Racom website and let me just go back to this and show you an actual simulation. If you go onto the Racom website and you can see here racom.eu is the URL. You come down here and you just go onto microwave links. You can then scroll down to this. All of the information here is provided. One of the very nice things about Racom is that every single piece of information you want about the product is available on the website. You don't need to register to download data sheets or any silly thing like that. It's all publicly available. On here, I'll take you through this section with a bit more detail, but on here there is a section here under calculations, and this is an online link simulator. And rather than doing that, because it takes a while to set it up, I've got one here where I've actually set up, and this is for the link that is actually running, not that I've set up a simulation which is not too far from where ISP Supplies is based. I've just set up shown a link here running just near College Station, actually between the airport and a hospital. So here, you just, in doing this, you set the RAID product, and I've got here the RAID 24. I've set a channel spacing with a maximum 112 megahertz. It's worth saying that this simulation is based actually on a horizontal polarization. As we talked about earlier, the vertical polarization has somewhat less attenuation. This one assumes a horizontal, so it is worst case. I've set it with a maximum power plus 10 dBm. I'm actually using a 2-foot dish here and set it to the point, and you can see on the little map here, it shows the two ends. It then shows a terrain. And what's interesting here, as you can see, this is the first Fresnel zone. And unfortunately, there's a bit of the terrain here which is sticking in the middle of it. So this would be a problem deployment as it stands. But if I go back up here, you can see there's a section here where I've got antenna height. It's currently set at 15 meters. If I set it to 20 meters at each end, and then just hit recalculate, we can now scroll down and we can now see that we're missing the building, the terrain there, line of sight between the airport and the hospital. And if we scroll down a bit further, you can actually see the sort of performance that you would get. Now, in this particular case, you can see the different modulations all the way up to 2048 QAM. It won't do 4096 QAM with the 112 megahertz bandwidth. You need to have, it will only support that at the 56 megahertz bandwidth. But you can see at this 2048, you would get a throughput here of a little over a gigabit per second. There was only 5 dBs of fade margin in this particular case for this range with this antenna chosen. And with the rainfall availability that we would expect in the multipath, we're not getting a link availability, which is really the sort of thing that would give us a lot of confidence. If you set this thing up, this link would run and will run quite happily at 1 gigabit per second with 5 dBs fade margin until you get some weather coming through, and then you may start to have some problems. So this little simulator, you can see here where it talks about calculation accuracy. It does mention this ITU standard for rain attenuation and multipath fading. Some other losses are indeed are not taken into account. So this, as a simulation, is not something that is 100% accurate. If you want complete accuracy, you should probably use something like path loss. But nonetheless, this gives you a very good idea of the sort of performance that you would expect. So what we can do for this particular simulation, if we want a bit more throughput, for instance, we will change the antenna type. So I'm going to put a 4-foot antenna at either end of this link, and we will do a recalculation. And we can see when we do that our 5 dB fade margin at 1 gig has now gone up to 16.8 dB's fade margin, which is much better. And you can see the availabilities are definitely quite a bit improved, and we should be very confident being able to get a throughput of over 600 to 700 megabits per second, really under pretty much whatever weather condition that you would expect. So that's the a little run through on the simulation. If anyone after this wants to have a play with it, I'm more than happy to show them that individually. So let me go back to this. So this was the deployment that I've just shown you, the simulation. I did another one, and I've actually done another 4.6 mile link, but I just picked it in a different part of the US. I actually did this one here in Nevada. You probably can't see the numbers again because it's not that clear, but the thing to note, if I toggle between the two slides, is that the availability is significantly more, again, here in Nevada. And the reason for this really is just simply the change in the rainfall data in that region of the US over where ISP suppliers are based. So it does make really quite a difference. Okay, what I'd like to do now is just have a quick walk through the GUI. And if I go back onto the website again. So as I said before, one of the nice things about Racom is that they really do make everything available to you. And with that very much in line, they have in their labs in the Czech Republic a link running. And on the website, you can actually physically log on to a real live link, and the login credentials are shown there on the web page. As long as I've typed that in correct. So this is the live system running, and I've logged into one end of it. On the website itself, if I go back to it again, this link goes to one end of the website of it. This link here is the other end, the device at the other end, and then you can see the admin and the Racom demo 1, 2, 3, 4 as the credentials. So it is a live system. As I said, you can have a look at this. At the moment, it is running with 112 megahertz of bandwidth in each direction. They can do this in the Czech Republic, and there's a gigabit in each direction, happily flowing there. Let me just walk through some of the settings of this. So if I go back to that, go to this a little bit more here, you can see the polarization of the local device we're logged into. That's on a horizontal polarization. The polarization of the other direction is vertical. The polarization is simply set by when you install the unit, how it's mounted, and how you bolt it on. It knows which way up it is, so you just deploy it in the right direction, and it will then update the polarization here in the GUI correctly. So you can see all the relevant information down there quite happily. What else can we pick? Walking through this. So you can see here in this particular display, this is where you set the particular channels, transmit and receive channels, the modulation, and also whether you want to set up the coding modulation scheme, what the maximum you want involved with that. And then also you've got the adaptive transmit power control. In this case, it's not actually enabled, but you can set that up and what the threshold is for all of that. Onto the switch, I did talk a bit about the switch and just mention that. There are actually 4 ports on the switch inside the product. You've got Ethernet 1 and Ethernet 2. In this particular case, you can see that Ethernet 1 is being used. Ethernet 2 is not being used. No SFP module has been installed. The other 2 ports on the switch, one of them goes directly to the CPU, and the other one is obviously to the air interface itself. The interface through to the CPU is really for management information. To the things on the other side, and you can see here it produces all the full stats of everything there that that you would need. So this is some of the port data there as well. Let me just jump on to some of this. Here, this is the sheet where you do any backups. So you can do remote backup to this thing, change anything like that you want to do, or if you want to do a software upgrade or anything like that, that can be done there. Here, this is where you load any software keys and features like that. You can update those, all that sort of stuff. So everything there is very flexible. This is some live data. What is actually happening? You can look at obviously signal strength and signal quality as well. This is sort of similar really to signal to noise, modem mean squared error. So you can see that data there. And then this is quite a useful feature, the little spectrum analyzer. This will run an analysis on the unit itself and will allow you to have a look at what the spectrum is. So you can see here, this is because the actual, it's receiving signal coming in. This is the received signal. That doesn't show you any interference, unfortunately. If I click this little link here, I can disable the far end. So what we should be looking at now when we do this is just going to be whatever background noise comes in, and you can see that there. In this case, in the lab, it's obviously quiet, but in a real deployment, noise there. Based on that, you can then make sort of decisions upon how you want to set up your channels. So that, I think, is a brief history through that. Oh, what else can I show you? One other thing that may be worth looking at is services. Yes, on this screen here, you can see SNMP. If you want to run SNMP, it shows you where you set up the community string, your SNMP trap, IP address, all that sort of information you set there. So there's that you can set up, and then you can obviously set up any alarm information as well that you want, and how that is configured. And there's all that information there. So that's a brief and quick sort of walkthrough of the GUI. If anyone wants to have a play with it, please log on to the system and enjoy. If you want one of the engineers to walk through this in more detail with you, please talk to the team at ISP Supplies, and they can get that arranged. Back to this. So I'm going to finish that now. It's the end of the presentation. So if there are any questions, on this slide here, you'll just see the contact details for any of the organisations that are relevant. But your first port of contact is obviously ISP Supplies, and I've given their phone number and contact details there. So,
excellent. Thank you very much, Philip.
I will hand it back to Jonathan.
So thank you, Philip. We had a few questions roll in. Go over a few of these. One of them is, what sort of switch configurations can be supported for the 2 Ethernet ports?
Okay, that's a good question. Let me go on to the Racom website and see if I can find that. Along here, you will see a whole load of tabs, feature specifications, references, accessories, calculations, and downloads. Calculations we've already looked at. If I just click on downloads, here you've got a lot of information available. You can obviously download the manuals and everything. But this particular question, if I go and open up application notes and scroll down, there is switch setting examples. And if I just open up this PDF, let's get this here. Right. This document is free to download, and let me just set it up. So this kind of just shows some of the default configurations really of the switch. But the easier way to look at this is actually some of these other pictures. So here you can set it, for instance, so that you can loop back traffic from Ethernet port 1 to Ethernet port 2, which may be useful if you're wanting to daisy chain links onto other radios and other systems. Scrolling down a little bit further, things like VLAN IDs, that is supported, so you can prioritize traffic running across the system. Scroll down, pick another one. You can also prioritize based on MAC addresses. What else have we got? Oh, this has got a useful one. This is where you actually have traffic where you've got 2 separate customers on the link, and they each wish to have their traffic genuinely, completely isolated. So here, traffic from Ethernet port 1 will be routed purely to Ethernet port 1 on the other side, and then Ethernet port 2 to Ethernet port 2 on the other side. So there's a lot of flexibility in this that you can hopefully meet any requirements that you have.
Thank you very much. Yeah, it seems it seems that there's a lot of useful information and resources on the Racom website. So we certainly do encourage everyone to visit their site, click around, and learn a little more about the product and about everything that they have available right at your fingertips there. We have another question here. I hear that the radio is available with different software keys. Can you please explain how these work and how they can be upgraded? Okay, yeah, that's true. To be honest, there are 3 software keys. Let me see if I can just find the bit that kind of describes this nicely. I think it's in here from memory. Yeah. This probably is the easier way to see it. Basically, the software keys really relate to a throughput capacity. The base product is with a 360 megabit per second limit, and then you can upgrade to a 500 megabit capacity, and then also the 1 gig capacity. And this little throughput chart here shows the sort of different bandwidths and channels that would be relevant to. But to be honest, we find most of the time people just go straight to the 1 gigabit per second system. And in fact, I would say that from memory, when I last looked at the product that was on the ISP Supplies website, they're all there with the 1 gig capacity. But if somebody does, for instance, have a link that they want to go over a very long range, and they're not really requiring too much capacity, the trick there is that you would reduce the channel bandwidth right down to a low level. And that means that you can get somewhat greater range out of it. And in that case, you can probably save yourself a few bucks and just have the base 360
megabit per second rather than the gigabit. But most of the time, people are bothered about maximum capacity.
Thank you, Philip. And also, if anyone requires assistance with upgrading any other units with any software keys, you can please just email support@ispsupplies.com, and we'll be able to assist you through there as well. One more question came in. Are there any references for a Ray3 link in the U.S.?
Yes, there are. There are a number of links deployed. I think the first port of call I'd say for that would be to contact support at ISP Supplies, and they will then direct you accordingly. But yes, absolutely, there are a number of deployments. So yes.
Excellent. Thank you very much. And that concludes all of our questions for today. Once again, we'd like to thank you, Philip, for going over all of the information. If anyone has any additional questions, please send them to sales@ispsupplies.com, and we will get those answers for you. Also, please email us or give us a call at 855-WISP-PRO to go over pricing and availability. We will be posting a recording of this webinar on our YouTube channel, which is youtube.com/ISPSupplies, as well as our Facebook page, facebook.com/ISPSupplies. So please make sure to subscribe and follow us if you haven't already. I hope everybody enjoyed today's webinar. Please be safe. Have a great rest of your week, and God bless.
Thank you very much.